In this video, we'll be going over binary tree maximum path sum. So a path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. A node can only appear in the sequence at most once. Note that the path does not need to pass through the roots. The path sum of a path is the sum of the node values in the path. Given the root of a binary tree, return the maximum path sum of any path. So for example, given this tree, and then the maximum path sum we can get is 2, 1, 3, so we get 6. And our second example, we have this tree, and the maximum path sum we can get is 15, 20, and 7, which has a sum of 42. We can see that the maximum path does not need to go over or go through the root node. Let's go over the thought process. So for each of the node x, we will first want to find the maximum path sum of its left and right subtree. Then the maximum path sum we can find at x is equal to x.val plus the maximum path sum on the left plus the maximum path sum on the right. We should note that we do not want to include the maximum path sum on the left if left is less than 0. This is because any negative value added to our current sum will only decrease the current sum. This is because any negative value added to our current sum will only decrease the sum. And the same rule will apply for the right subtree. Now let's go over the pseudocode. So we're going to create a reference class, maxSum, to keep track of the maximum sum in the input tree. We do not want to create a global variable to keep track of our maximum sum. So there will be a single field value, which will initially be integer.minValue. Now we're gonna implement the recursive approach to find the maximum sum. And then what parameters do we need? We need the node, the current node we are visiting, and then the maxSum is the reference class or reference object to keep track of the maximum sum or maximum path sum. Then what is the base case? If node is equal to null, then there's no value here, so the sum is equal to 0. So we just return 0. Then each of the recursive call, we're going to recursively find the maximum path sum of the left subtree. We're going to default left to 0 if left is less than 0. So basically, if the maximum path sum of left is negative, we do not want to include it. We do not want to include it, so we're going to set it to 0. Then we recursively find the maximum path sum of the right subtree. And then say similar thing, we would default right to 0 if right is less than 0. Then we're going to update maxSum.value if node.val plus left plus right is greater. Then we can return maxSum.value. We can in the recursive call we'll return maxSum.value. No, we will return node.val plus left plus right. Actually, no. We want to return the path between the two subtrees that has a larger value. So we're going to return the maximum value between node.val plus left or node.val plus right. Let's go over the time and space complexity. For the time complexity is O of n, where n is the number of nodes in the binary tree. And we visit each node once, and our space complexity is over h, where h is the height of the tree. This is our recursive call stack memory. Oh, it's node.val plus writes. Now let's go over the code. So we're going to create our private class maximum sum to keep track of the maximum sum path. And we'll first create our instance of maximum sum. Then we're going to implement a recursive approach to find the maximum path sum. And then we'll return the maximum sum.value after we find it. And then we can implement our recursive approach. The base case is when node is equal to node, there's no values left, so we can return 0. We'll first recursively find the maximum path sum on the left subtree. We would default this to 0 if it's less than 0. So we do a math.max here. So basically, if the maximum path sum of the left subtree is less than 0, then we're going to default to 0. Similar on the right subtree. Now we're going to update the maximum sum if the current path is greater, or the current path has a larger sum. So it's node.val plus left plus right. Now we want to return the longer path, or the path with a larger sum. Node.val plus left, or node.val plus right. We only get to pick one path. Let me know if any questions in the comment section below.